Okay, I think we're live. Welcome, people in the future. No one's joining me just yet. I put this. I did plan. I did talk to some people about doing a Sunday stream on Specialist Maths, but I didn't set a time, so I'm not surprised that people aren't looking out for me. So yeah, I set a time about a little bit over an hour ago for about 15 minutes ago. So sorry I'm late. Actually, sorry, no. I'm 45 minutes late. I was meant to start at 7, I think. I had a few hitches with my internet. My router, I didn't realize, fell down and disconnected itself. So I had to sort that out. And it was kind of partially connected. So I wasn't fully aware what was going on until I actually went and checked the router physically, see what's going on. I was trying everything else but that. I was trying all the right-click solutions on my computer. But yeah, I figured it out. It's all sorted. Okay. Now, a few things before we start the practice test is what I'm going to go through later on. But I need to make people aware of a few happenings. Okay, I'm going to be changing the account that I do my education work. Now I'm going to try to make that seem seamless. So unless you subscribe to me on this particular channel, you will not notice it. If you follow me through things I put up online, Moodle and such, then you can just click on the next one or click on the old one, and hopefully all the links will be updated to the new place. Okay, this has happened because basically, okay, I do a lot of content on YouTube of varying sorts. Nothing that I really am upset about, but just it's usually a professional. It's in the best etiquette to separate everything in your life into categories. Like, so you take the stuff you're doing for work, and that just stays at work. You don't bring it home unless you really need to. And same thing, you do stuff at home that you wouldn't bring into work. If you do other sort of work, you don't necessarily want to mix up your two workplaces. That can cause problems. So I'm trying to make these analogies as to ways that students would understand it, like students of ages 15 through to 18 would get. The only thing I could do in comparison, imagine if you like video games, and you love going home, you love playing video games, and you might talk online with your buddies in video games, and you might say some things that you would not say to your grandmother, or things you may not say to your principal or your teacher. That's what I'm talking about. So yeah, you got to keep things separate, and your girlfriend or your wife or your boyfriend or husband, well, whatever. Yeah, you can understand the distinctions that we all wear many faces. I think that's the description I would make. So I just want to make people aware of that. So if you wonder, okay, where did all the videos go? If you go and find me on YouTube, this channel will disappear within a week. And you might, if you've already kind of looked at me up recently, you notice that I've closed a few links to various things. I've changed my subscriptions, yeah, that's basically the first step of what my transformation. Okay, I do want to announce my new channel. So when it's ready, you guys will be aware of it. The name will be something on the lines of Woolly Mammoth, or Woolly Mammoth Education, or Woolly Mammoth Teaching, or Woolly Mammoth Math, or Woolly Mammoth Studying. Something to that effect, something with the Woolly Mammoth in there. And there's a reason for that. It's a little nickname that was given to me by one of my former students, a lovely young woman. I won't mention her name, but she was I think she's one of you don't really like to have favorites, but I've had her. I remember teaching her for over 2 years, and there's a lot of character there. She was the only girl in the class in one of those classes, and she took a lot of my classes. So I remember as the only girl in a few of them, yeah, and she I was actually fairly overweight at the time. I'm not now. I'm actually very fit. Take my word on that. I'm not going to show you my photo in a minute. But basically, yeah, she'd they all tease me about my weight from time to time, and she gave me the nickname Woolly Mammoth. So that's where that came from. I can't remember how it started, but it kind of stuck, and I thought, whatever. And I think it had something to do about me being very wide and blocking the whiteboard, or something to that effect. And also, I'd wear a lot of kind of cotton jumpers and things like that at the time. Something like that. I can't quite remember, but it kind of stuck, so I'm going to use it. So that's going to be my kind of my education persona, if you like. It's also going to be the name of my new business, which has been floating around for a while. I've had this business, education, tutoring, education, instruction / media / books and resources, and I haven't made it official, but I made a lot of content, and yeah, I will. That's going to be the name of it, unless I make a decision otherwise. So yeah, look out for Woolly Mammoth. He's going to be on the scene. Okay, so kind of since I'm on this theme, I wanted to read out kind of a brief mission statement. Sorry, I took a few notes, but everything's been falling apart, like I mentioned before, with the internet. So I'm a little bit rushed, and I want to get everything done before it gets too late. So, but I do want to read this stuff out because it's kind of important in terms of the future of what I'm doing with this channel. Okay, so Woolly Mammoth. As far as the YouTube stuff goes, if you're familiar with an outfit known as Khan Academy or variations thereof, you will probably recognize the theme of what I'm trying to achieve with this channel. So I'm going to be a bit like them, and they do a lot of content in kind of lecture form with kind of drawing out things, and that's how I got the inspiration of how I'm doing a lot of the stuff I'm doing now. But with advancements in software and a bit of investment, I reckon I can make the content better. Basically, I will be delivering similar content, maths and science themed stuff, particularly physics and maths at higher ends, but I will go and do other things as well. I will have to teach myself a few things to be able to do that. I am familiar with general science, chemistry, biology, but I want to sharpen my skills before I go start teaching that and try to teach content. I want to make sure I know what I'm talking about, and that I can answer questions quickly and efficiently. Okay, but basically the way Khan Academy kind of fails, and I think I'm talking about Khan Academy, or maybe one of the equivalents, but they all have a similar kind of thing. There's some really, really, really good channels out there who do really, really good work. There's one history channel which name eludes me, but yeah, he does really funny videos. You might know what I'm talking about. So look it up. Look up school history YouTube, and you see what I mean. Okay, but Khan Academy, where it fails is basically he's reading off much in the same way I do, and kind of drawing using some sort of drawing tool, much in the same way as I'm doing now. But there are many, many better ways to do this. So I'll be doing similar content, but in the future, it's going to look a lot more professional. And that's not going to cost me too much. I've put a fair bit of coin down already to get microphones and cameras, equipment, and it's going to come down to software and maybe a few more hardware devices, such as a stylus pen or something like that. And I'll be able to do it, and it's going to look better. It's going to make a lot more. It's not going to be so messy and like I've drawn it with my finger, which is how I'm doing it in the minute. That's how I do all the math problems. I draw it with my finger on the actual screen of my computer. That's how it's done. I've shown you behind the curtain. That's how I do it at the moment. But I know I can do it better, and that's going to happen, and it's gonna look pretty cool when I get this all up and running. Okay, moving on from that though. So that's how things are going to change. That's how things are going to improve. A couple other things I want to get done with the YouTube channel is I'm going to have an open question portion of what I do. We're basically, now there's a few ways this format's going to go, depending on there's a few things, a few legal hitches and a few other things like that. I really appreciate the support that people have given me so far, and the advice that people have given me. I have to seek out a lot of advice about this stuff because, particularly when you're dealing with people under 18, you've got to be very careful. And people have given me a lot of warnings and a lot of advice, and I've taken up a lot of that advice. I really, really appreciate it. If anyone's got advice they want to give me, please message me through whatever connection that is attached to these videos. I'll try to make sure that's up to date. But and to my point though, so the theme I want to get for the open questions is basically students can ask me to answer maths questions or science questions. So you can just send your questions to me, and if I see them and I haven't covered it already, I will endeavor to do them. If I have covered it, I'll probably just say, okay, link, here you go, link to this video. Or if there's something, if someone else has done something I think is better than what I might be able to perform, I'll say, okay, watch this. This will explain it to you. Okay, and all right. Now, issues that are going to come up with that and matters of consent. What I mean by that is, okay, it's either going to be kind of open in the fact that you can jump on the stream and ask questions or send me stuff and just talk to me about it on the stream, which would be kind of cool if I can pull that off. I know I can pull it off in far as I can get people online, but what I'm worried about is just talking to young people on the internet is a bit of a gray area, and I need to make sure that everyone and everyone's parents are aware of what's going on, and that it's all kosher and everything is fine. So I'm going to look into that and see what I can do. If it's unworkable, I'm going to scrap the idea, and then all I'm doing is videos like these where you just will log in and you might watch me do it live, or you watch me you watch it later, and you see what I'm working on. I'll suggest what the theme will be ahead of a time, but you actually see me working on problems, and you won't be able to interact with me. I'll just do them. There will be no chat room. There will be no message board or anything else like that. That stuff will all be locked if I can't find a way to work in this. Yeah, you won't be able to talk to each other or to me while I'm doing it, is the theme I'm getting with. Okay, the other thing would be teacher consent. Okay, so the thing I'm concerned with is too many kids are going to come to me and just send me stuff like, okay, here's my maths homework, here's my maths assignment. They probably say, okay, I just need help with this worksheet, and they won't tell me it's summative work or it's graded. They won't tell me that, and they're going to go to their teacher. They're going to hand up something, and the teacher's going to go ask them, oh, did you really do this? And they'll say, yeah, I really did this. And of course they didn't. I did it for them, or I explained it and they just kind of jotted it down in a way that doesn't look like their work. And from that, I'm hoping that I'm going to get the students to give me their teachers' names and their location. Like where do they work, a rough location, the name of the school, and where the school's located. They don't have to give me their private phone numbers or emails or anything else like that. I will actually probably message them just ahead of time and just say that, or if I can, if it's given, like if there's details given, I will message them and say, look, I'm going to do Johnny's worksheet that he gave me. So yeah, you're aware that I'm doing this, and And yeah, if Johnny comes in and he got a straight A for his assignment, just be aware that I did that work, and just double check my sheet, double check kind of my video, and make sure that Johnny knows what he's doing. So the teachers can always test you. If the teacher doubts and they have time to test you, what they'll do is they'll just they'll take you and they'll sit you down and say, okay, they'll give you a sheet that's like the sheet they got and say, okay, show me how you did this. Or they will just take the worksheet that they gave you in the first place and just remove your answers and say, okay, show me how you do this again. Like you might be standing up at the whiteboard and say, show me how to do this again, please, Johnny. Now, if Johnny doesn't know how to do it, if Johnny learned something from what I taught them, Johnny might be able to pull off most of it. But if Johnny just wasn't really paying attention and just transcribed my answers, then that's not going to help Johnny. It's not going to help the teacher. It's going to be a pain in the rear end for the teacher. And the teacher would notice, okay, Johnny, you really don't know how to do this. Who helped you do this? And there's nothing wrong with helping people do things. I mean, I tutor privately all the time. I'm very busy. But yeah, I just want to make sure that my system is going to be used effectively and not abused. So you see what I mean with that example. Okay, now I think that covers the stuff I wanted to talk about prior to starting. So, okay, I'm just going to get the show on the road. All right, so what we're doing today is we're actually going to be looking at a specialist maths test. Now, I've got the solutions loaded up and ready if I need them, but I'm going to try to do it without them. So let me just switch over to this and we'll take a look. Okay, now I'm just going to double check to see that you're seeing what I'm seeing. Okay, so okay, it looks very much like you're seeing what I'm seeing. So, all right, just going to click present to everyone, make sure that's fine. Okay, now that seems to be working fine. So okay, let's crack on. Let's get some maths done. Let's actually do some maths questions instead of listen to me talk about my future plans. Alrighty, okay. So let me just shrink this down, what I'm looking at the moment, and now I'm seeing what you were seeing, and now I'm seeing that too, if that makes any sense. If it doesn't, don't worry about it. I'm just being technical. Okay, let me just move the mic a little bit. Actually, no, I'm actually going to switch the side of the mic. Pardon me a moment while I just reorganize everything. It's just going to be easier this way. Okay. All right, now just moving a few more things around, pardon me. Okay, and I'm just going to have myself a little drink here. Okay, awesome. All right, so not to worry, everyone. Let's have a look at the volume settings, see if you're hearing me all right. Okay, the volume settings seem to be peaking quite nicely. I don't know how the audio is at the moment. This microphone is relatively new. I've got a pop filter on it, and it's got a little stand, and it's quite nice. It's the one I used for the last video, but not the one before that, I think. But that one was kind of dying. It was actually more to do with the Windows setting. But again, I'm yammering on about stuff that isn't entirely important. Okay, so I just thought it was important to move the microphone to my right side so I can actually write on the screen with my left hand instead of bumping my elbow against the microphone like I did last time all the time, which you might have heard. You might have heard me just covering my mouth when I said a little swear or something like that. I think I checked the video, nothing came up, so I'm quite happy that I'm keeping things professional, and that's the main goal of what I'm trying to do with my work in the future. Keep it professional, keep everyone happy, and yeah, just keep it cool. So okay, now I'm done being a silly bugger. Let's crack on. Okay, so
You're seeing what I'm seeing, and hopefully you guys can see question 1. Okay, now I'm putting this all on one screen. I can enlarge the test. In fact, why don't I just go and do that? Pardon me a moment. Okay, so yes, I'm still not 100% organized. Okay, yeah, apologies, we're starting very late. In the words of Fidel Castro, we're going to end early. Now, what he meant by that is that if you don't know, Fidel Castro, the former leader of People's Republic of Cuba, let's call it Cuba. Yeah, and he's known for his very long-winded speeches and a number of other things which I won't go into since I'm not doing a politics talk through. But yeah, Fidel Castro, one thing he's really, really well known for is giving very, very long speeches that drag on, and some people find it very, very, very boring. Some people like it, some people do not. But anyway, people who people who listen to Fidel Castro's speeches, one incident I recall, he said he gave a speech and he was running late, and he said something like, "I'm sorry, I'm running late, but we will finish early." And by the end of giving his speech, it was, I think, 3 in the morning, like 3 a.m. And he finished his speech, and then he says, "I told you we'd finish early." And everyone kind of like had a little chuckle. People who were still there watching had a little chuckle. So that's my joke. Okay, so I had to spend a fair bit of time explaining that joke, so it's not necessarily a very good one. All right, let's get on with it. Okay, so again, one last check. I'm just being super paranoid about everything. Okay, so you can't see. You're having trouble seeing what's to the left of the numbers, but that's all you really need to see. This test is on vectors, and okay, so that now you can probably read this properly. If you're viewing this on the screen, like a little screen at home, or if you're viewing it on an iPad, I might try that myself at some point. I'm going to look at my videos through an iPad and see how well they look. My videos are not designed really to look at them on a phone unless you've got very good eyes. I do have very good eyes most of the time. I'll premise that by saying I score better than 20/20, or at least I used to when I was in the military. I used to be able to read the bottom of the eye charts with one eye. Okay, again, I'm yammering and yammering and yammering. Let's get on with this. Okay, question 1. Find all vectors parallel to I minus j plus 4k with length of 3 units. Okay. Pardon me. Okay, so let's talk about I, j, and k. Now, I, j, and k are your direction vectors in the x, y, and z directions, respectively. All right, so let's remind ourselves of that. I. Okay, that's not good. So my notepad is disappearing. Why is my notes disappearing? That's not good at all. Don't disappear. Stay. I want you to stay. Please stay. Oh, they're underneath. Why do they have to be underneath? Okay, look, I'll close that down. I've got a simple work through solution for this. I promise this will work. I promise you this will work. Okay. All right, my work through solution is I'm going to write on the right-hand side with white texter. Ingenious. Okay, let's have a look how that works. I equals, there we go, 1, 0, 0. Brilliant. Aren't I brilliant? Just have instantaneous solutions for unknown problems. This is what I get for not testing things out in advance. Okay, so those are your unit. Whoops, that's a 0 and 1. So 1 unit in the x direction for I, 1 unit in the y direction for j, and 1 unit in the z direction for k. That's what ijk is. So tell me then, what is I take j plus 4k? Now, if you said 1 minus 1, 4, you are correct if you put it in a square bracket with commas, like this. So vector v, whoopsies, get my pen back, vector, we'll just call it vector A is equal to 1 comma minus 1 comma 4 square brackets. Done. Okay. So find all vectors parallel to that with length of 3 units. Now, we want to find this with 3 units. There is a distinctive way to do this. Basically, you are going to reduce it to 1 unit, and then you are going to times it by 3, make it 3 units. Now, first of all, let's go through the modulus of vectors. All right, so the modulus of vectors will determine the length of the vector. Now, this is a Pythagorean concept. What we're going to do is take the squares of x, y, and z components and add them up. So, and you remember this Pythagoras from the Pythagoras a squared plus b squared equals c squared. Well, if you do that in those dimensions, and then you also include up a third dimension, you do a squared plus b squared equals c squared, and that's a diagonal that goes straight from the first corner to the end corner. But then you think about, okay, now we've gone across, now we want to go up, so we go up by c. But then the idea is you've got the length across the bottom is the square root of a squared plus b squared. And then you also, so you square that, and then you have plus c squared, and then you take the square root of all that. So you've unsquared the square root by squaring it, and then you add the c squared. So it's a squared plus b squared plus c squared equals length. So let's do that. So squared, sorry, for those, I'm not writing down notes for that. You can look it up yourself. Do your own little research if you're uncertain that this works. Like draw yourself a rectangle prism, and then see if you can get work out call the sides x, y, and z, and then so like x across, like the width is x, the length is y, and the depth is z, and then work out algebraically how to find the distance from one corner of the prism to the other corner, which traverses all 3 dimensions. So yeah, you imagine you're holding it from the two extreme down distance corners, working out that length. That's how this comes to be. Okay, so all right, so let's find this out. So we've got 1 squared is 1, minus 1 squared is also 1, and 4 squared is 16. So we have the square root of 18. Okay, now from your search, the highest squared number that is a factor of 18 is 9. So 9 times 2 is 18. What that means is, okay, I can break that up into root 9 times root 2. But root 9 is 3. So it's 3 root 18 is 3 root 2. Okay, I hope you understand that. Now, that makes things quite a lot easier than you would think, because basically we know this has a length of 3 times root 2 length units, but we want it to be 3 length units. Okay, well basically you can divide out the root 2, but just to make this formal. All right. Now that doesn't cover all vectors parallel. Okay, that covers 1 vector parallel. Sorry. Okay, parallel. Parallel. Okay. B is equal to Ka. If you have two vectors that are parallel, B is equal to scalar number K times A. Now, in this particular case, B equals 3. No, sorry, that's not right. Well, B has length of 3. So if the modulus of B is 3. Okay, but if we make A a unit vector, we can essentially times that by 3. Okay. Now, so the way I'm going to do that is, okay, back to my pen. Now, the plus or minus, because this is the part that says all vectors. This is what it means by all vectors. There's only two vectors with that direction and that length. One going the same way as A and one going the opposite direction as A, the minus. All right, plus or minus 3. So it's going to be 3 units long. Now, what I'm going to put in here is algebraic. I'm just going to put a little notation, which is going to denote the unit vector of A. Okay, A divided by its own length is this unit vector. All right, so we understand that. Okay, I'm going to scrub out. No, actually, I'm just going to continue this. I'm just going to write a couple things more. Okay, so plus or minus 3. Now, I'll put A is still going to stay up there. And then I'm going to have the 3 root 2, because that's its length. So plus or minus 3 times A divided by 3 root 2. Cancel the 3's, okay? 3's are cancelled. Times 3 divide 3. They're gone. Still got plus or minus A over root 2. Now let's deal with that. Okay. Now, I'm going to get rid of, okay, so you've got that concept down. Let me just erase all this stuff. Okay, so we know we know what we want is plus or minus A on root 2. Sorry, I haven't used this actually this way before. There's probably, I can probably just use a thing where I can just highlight everything and just delete with one button press. But this is kind of cool. I'll just highlight everything. There we go. Oopsies. Still got a bit of... There we go. Okay. So, okay. What did we have? Say it with me. Plus or minus, because I've problems with my short-term memory on occasion. That's what we had, didn't we? Yes, that's where we were. Okay. B is that. So, let me just undo that. Oops, redo. Why did I do that? Okay. Apologies. Sorry, I'm just. I wanted to write that out a little bit better than what I was doing. Okay. Okay. Sorry. Pen back. Okay. B equals, vector B equals 1 on root 2 times vector A. So that's where we're up to so far. Yeah, root A divided by, vector A divided by root 2 is the same thing as 1 on root 2 times vector A. That's often how we write it, because that's the K. That's the K times the vector to make the parallelism. Okay, but what we need to do now is times that inside the vector. Okay, so 1 on root 2. Now, sorry, this is plus or minus. I'll keep the plus or minus on the outside. Forgot about the plus or minus. Yeah, the plus or minus is important. We'll deal with that in a minute. Okay, so 1 times that is 1 over root 2. Minus 1 times that is minus 1 over root 2. Okay, then we've got 4. 4 on root 2. Now, I'll put a little side over here. 4 on root 2, 4 equals 2 times root 2. Oh, sorry. Not going to work. Try it one more time. 4 equals 2 times root 2 times root 2. Okay, 4 equals 2 times root 2 times root 2. All right. So let me write that out one more time with the plus or minus. Then we're going to break into the two actual solutions. If you wrote out this line with the plus or minus 1 on root 2, minus 1 on root 2, and 4 on root 2, I would say that most likely most teachers would mark this as correct, and I would too. Because you've got the general idea, you've worked out what's going on, you've proved that, you've shown the parallelism, and you've done the number crunching. So this is just a little simplification, which is just being a little bit more Puritan. I'm being a little bit more pure about what I'm doing here. Okay, now these are still the same. Okay, 4 divided by root 2 is 2 root 2. All right, now my two answers are what I just wrote. That's the plus case. And the other case, the negative of that. Okay, that was messy. Okay. So the last one is minus 2 on root 2. If you're having trouble reading that, so I apologize for that. Yeah, that's so that's that question done. So those are your two answers, and I'll just have a quick look. Okay, through to unit vector length, all vectors, length 3, yes. And you see they've written it sort of different. They kept the 1 on root 2 outside, which is I brought it in. So the accepted solution was even just having the a and then plus or minus 1 on root 2 on the outside, and then just having those two solutions. That seems to be fine. Okay, so that last little bit was just a little help, just to explain that a little bit better. It's something you might be required to do. Okay, let's get rid of everything. All right, squiggle everything, as we're going to do a new question. New question time. Okay. All right. Question 2. Prove that points, okay, A, B, C are collinear. Now, there are a couple of ways to go about doing this, and I'll explain briefly. One is using the concepts of parallel lines. If you've got 3 points, you can construct vectors. You can construct 6 vectors in total, 2 pairs of which will be anti-parallel. One travels one way, one travels the other. In other words, like AB has the same length as BA but opposite directions, and so on and so forth with other combinations of the same letters. But we're going to write out 2 independent vectors, which and we're going to show that they're parallel. So the 2 vectors will share a point. So each of them will have one of the same letters, but the other ones will be different. Okay, now just looking at that, so let's have a look at the numbers that I'm looking at the moment. Okay, have a look at the X number for C, -1. the x number for A is 1, and then the x number for B is 2. Now that's in order. Start again. C, A, B. All right, so let's look at that again. C minus 1, A 1, B 2. That's in order. Now, if they're parallel, that should be consistent throughout, the same sort of order, or a completely opposite, so long as they're following the same direction in each component. So minus 9, negative 3, and 0. Yes, those are all increasing. And the last one is going 4, 2, 1. They're decreasing, but that's the same order. Still C, then A, then B. So that's consistent rankings in terms of the numbers there. But let's show that they're parallel. Okay, so what I'm going to do, I'm going to use in that theme, I'm going to do vectors C to A and A to B. Okay. All right, now C to A. I'm going to do this in the shorthand fashion because that's what I've been teaching. And if you look up the longhand, basically you take final, take initial. Final is 1, initial is -1. 1 take -1 is 2. That's how you do it the long way. And then you substitute all those in and work them all out separately. The way I do it quickly is I look at the motion from point 1 to point 2. So for example, C starts at -1 and you travel to +1. Now think in terms of your number line. -1 is 1 unit to the left of 0. +1 is 1 unit to the right of 0. So how far have you traveled and in what direction? So if you've got, I'll just put a little number line up here so you guys can follow along at home. I'm going to squeeze a little number line. Let me just change colors. All right, so we've got -1, -2, 0, 1, 2, 3. Okay, so if I go from -1 to +1, let's have a look. 1, 2 units in the positive direction, so that's a +2. All right, now C to -9 to 3. Now I'm not going to write out all those digits, but -9 to 3. Have a think about it. -9, just count up with me in the transition. You start at -9, you haven't traveled anywhere yet. -9. Okay, number 1, -8, 7, 6, 5, 4, 3. Okay, how many fingers have you got hanging out? You should have 6. Does that make sense? You've traveled 6. What direction? In the positive direction. We've moved to the right in our number lines. We've moved from a very far left position of -9 to a less negative position of -3. And we moved 6 units. So that was 6. Okay. Now the last one is, so I'm going to just change colors so I can write that up. Okay, so I just said 6, and that one was 2. So 2, 6. So I hope you're look, you can do it the long way if you want by substituting final, take initial. People make mistakes with those because of directed numbers and negatives, but they also make mistakes with the way I'm saying it. So you've got to think about what I'm doing, and you've got to picture it. Draw yourself a little number line just like maybe in your notes just before you're about to go into the test. Just put a little number line from like -20 to +20. And trust it, if you just follow this, so you might remember doing number lines back in year 8 or earlier. I remember doing it in primary school, so which for me was I think year 6 or year 7. I remember doing number lines, and this is how actually I remember early in that. I remember my teacher who showed it, and I said I'll give you the small end of the antidote. Okay, I was in this was actually year 5. I was in year 5, and we were going to go through negative numbers. but no one knew about negative numbers. So the teacher there was just discussing like integers, whole numbers, and he said to the class, so you students, you all know that 0 is the smallest number. I said, and I said, oh, sir, what about negative numbers? I don't think I said sir at the time, but I probably should have. I just probably just called him by his name, the last name. I wasn't that posh or anything else like that. I was a bit of a rat bag. But anyway, yeah. So I said, yeah. What about negative numbers? He said, oh, Eric, don't worry about that. That's for later. So I felt a little bit I felt a little bit superior with that because I knew something everyone else didn't. So that's me being smug for the evening. Again, I spend a lot of my time showing off maths, so that's what I like to do. Okay. Anyway, moving on. Okay, last point. So we're still on the question part one because I've just been yammering and yammering and yammering. Okay, let's get on with it. Okay, 4 to 2. What have we traveled? Okay, 4, 3, 2. We've gone 2 steps. 4 to 3, 3 to 2. What direction? Negative. So we've gone -2. Okay. Hope that makes sense. I'm going to do the next one a lot faster than that. So let's see how we go. A to B. So we're looking at the 2 here. I'll just bring my mouse up. The 2 here. A, 1, -3, 2, and B, 2, 0, 1. Okay, I'm going to do this quickly. 1 to 2, 1 in the positive direction. -3 to 0, 3 in the positive direction. -3 to 0, you move 3 steps to get to 0 from -3. Hope that makes sense. Okay, +2 to +1. We move -1 in the negative direction. Did I just say that twice? -1 in the negative direction? Or 1 unit in the negative direction, or we just move -1. Okay, I hope that makes sense. Now, look at those numbers. 2, 6, -2. 1, 3, -1. What can you see? Can you see a relationship between those two? Hey, I reckon that 2 lots of AB equals CA. How about that? If I double AB, I would have 2, 6, -2, which is what CA is. Now, if you can't see that, just try to take out a common factor out of the larger one and see if you can make them match, or take a common factor out of both if they have it. Now, I knew where this question was going just by looking at the numbers. So that first little bit when I picked out which vectors I was going to do, I did them in the order of the x moving from left to right. So remember, I said C was the start. It was -1. All the other x's were positive. So I went from C to A to B. So that's why I went from. That's why my first vector was CA, and that's why my second vector is AB. So do you understand my thought process as I did that? If you can make little thought processes like that, it's going to help you do your maths a lot better. If you can plan things in a head. Now, that's not easy. That takes experience. But if you practiced enough math questions, so if you do your homework, if you did all the questions in the set, you can probably predict where this question is going and what you're trying to do with it. Now, I've just proved that these are collinear. Actually, what I've proved first is that parallel. Now, technically, the two things are not the same. Okay. Now, the direction is parallel. So you remember when you did your, you've all done, if you're doing this sort of work, you must have all done lines in space and geometric proofs of some variety. You might have not called it that, but you might remember like seeing little pictures. You might remember something like this. If I do this little drawing, yeah, you remember your angles that made up of that? Yeah. Okay. Yeah, parallel lines are not the same thing as coincident lines. Now, what they are is they both, in both cases, they have the same direction. Parallel lines have the same direction. Coincident lines have the same direction. The difference is, sorry, collinear. Yeah, they have the same direction. but collinear, the lines lay on top of each other. So like if I drew a line, A, B, and C lie on that line in a three-dimensional space. Okay, direction is parallel. Now the direction is parallel because, as I mentioned before, if you have vector equals number vector, then they share the direction. Oopsies, sorry, I'm trying to draw a little ampersand, little ant sign. Sorry, I'm losing control. Tonight's not my night. I'm having a lot of issues with a lot of things. The maths isn't too bad, but I'm stuffed up on a lot of things, so I've been a little bit jovial and I want to have a break, but I've only just started and I made promises and I intend to keep them. So apologies on my quality control tonight. It will be better in the future, I promise. Again, that's another promise I'm going to try to keep. All right, direction parallel, and the other thing is, okay, common point A. So the two vectors are parallel and they share a common point of capital A. Implies collinear. Okay. Are we happy? I hope so, because I'm not doing that again. I will describe briefly how you can do it other ways. Okay, another way to do collinear, to prove things are collinear, is, okay, you take the 3 points and you work out vectors much in the same way as we did, but you have to work out 3 vectors. Okay, let me explain how that's done. Okay, if you work out A to B, A to C, and B to C, apologies, I'm thinking this through. I don't have my textbook in front of me. If you take the cross product of the first two, you get a vector that's perpendicular to the first two. And if you take the last vector, take a dot product with what you did with the cross product, you should get 0 if it all lies on the same line. If they lie on the same line, it would imply they lie on the same plane. So that's true. Okay, now that's a little bit, I did that in my head. So apologies if that sounds very confusing. Consult your textbook and have a look for other ways in which how to do collinear proofs. So I've done one here, which I think is the most useful, because we're going to use this concept in a minute. What I just worked out here, the 2A B equals CA, in terms of something I'm going to go through in the part 2. So let me just delete. I'm just going to see if I can group all this stuff up. Kind of. Oh, yeah, that works. Yeah, I just press delete a few times, and then I say stop. I don't want you to delete anymore. Okay, now part 2, question 2, part 2. Let's get back into it. Draw a diagram showing the relative positions of A, B, and C. Okay, now it doesn't actually matter too much the way in which you draw this. I'm just going to draw a line. Okay. That's not a very good line, I know. I know I've got a drawing tool, but I'm not going to bother using it because this is a little thing. You draw yourself a nice straight line, and all you're going to do is just put your A, B, and C in relative positions. Now, okay. Again, now, you don't have to draw this in proper kind of coordinate space. So I'm just going to put a little point at the end of my squiggly, which is supposed to be a line. Oh, this is supposed to be a little mark. Whoops, I don't want that last bit. Look, I was just going to do it with a cross. Sorry. Okay. So you draw it with a dot. Now, that's my leftmost point. So that's going to be C. Now, this is going into 3 dimensions. So, yeah. Now, okay, you just have to do this in order. What they're looking for in this question, now I can tell you what they're looking for. Someone else wrote this test, but I know how they're thinking. I know what they want. So what they're looking for is, now you've got C is on the left, then comes A, then comes B. But think about your spacings. C to A has a certain distance. It has a distance. We didn't actually work out the actual distance because we didn't do the modulus. We don't need to. But there's a ratio of distances. Now have a think about it. From C to A, and I'm going to write a better A than that. Pardon me. So while I'm just doing that little squiggle, have a think about the ratios yourself. Okay, if that's C to A, where should I put B? Now, don't just think in terms of like is location in terms of A or C, like to the left, to the right of whichever one. Have a think about how far away it should be. Okay, if you had a thought about it, maybe just pause the video now, take a break if you want to really nut it out. Otherwise, I'm going to tell you, you need to place it. All right, spoilers. Click now, click pause right now. You're going to place it there. The ratio is, and this is giving away the next question, I believe. The ratio of that is not actually 2 length units. I'm pretty certain it's not, and that's not 1 length unit, but those are the ratios. Does that make sense? Because 2AB equals CA. So thereby, if I double AB, that's 2, and C to A is equivalent to 2. That's it. Okay, so I've given that away. Well, that's what I'm here to do. I'm here to do the math questions. Okay. Oh, that was actually part of the question. I just read that. All right. Hence, state the ratio in which B divides AC. B divides AC, but B is on the right. Careful now. B divides AC. Now that's external. Now, I'm going to double check that. Basically, now, think about it this way. Okay, now, that's purely in terms of ratios of length. Distance between B and C is 3 in comparison. So it's BC 3, BA 1. So my answer, and I'm going to double check this. I'm going to write 1 and -3, and I'm going to look down, and you're going to see, you're going to watch me, and you're going to see if I'm wrong. Okay. Now, it's either going to be that or the number's going to be switched the other way, unless I've really stuffed something up. So let's have a quick squiz. Let's go down. Now, this is question 2, part 2. So I said 1 -3, didn't I? Let's have a look. Yeah, I was correct. Excellent. That's a relief. Look, I don't mind getting things wrong or getting myself embarrassed. I've done it before, but I want to be honest. If I make a mistake and I figure it out, I don't like to just get upset about it. I just like to just acknowledge that I've made a mistake and correct my mistake and make sure you understand what my mistake was. I make a lot of mistakes. You might have noticed in the other videos. And sometimes I get stuck on questions. I usually try to bring solutions with me. like work something I've done in the past, but sometimes I'm just a bit busy and I just pick up something and I just try to run with it. And I usually do really well. I generally do, but not always. And I'm glad I got that one right. Okay, so that was me. Yeah, I took a bit of a gamble there. And I get worried sometimes that I'm going to lose my credibility, and I'm going to make a fool out of myself. Look, I've done it before, and I'll do it again. Actually, I'm not going to delete the number line. I'm going to delete the rest of this. So this is a quick way to do it. So I can just highlight. Actually, no. What the earth is with this little lasso tool? Is there an easy way to do this? Lasso. Okay. I see. You can swing it around like a lasso. That's why they call it a lasso. Okay, let's just practice the lasso one more time. Whee! Gotcha. Number 2. Okay, let's move you back in position. I'm going to keep the little number line there, so we might refer to it again later on. And I'm going to, okay, let's move on. So question 3. We're on to question 3 now. All right. All right, so we've got R is equal to that and S is equal to that. 2 vectors. Calculate dot product and cross product of RS. Now, start off dot product. Let's get this done. Dot product. Also known as the scalar product. But I call it dot. Why do I call it dot? Well, look at that. It looks like a big dot if I filled it in properly. It looks like a better big dot over here. That's why we call it the dot product. As opposed to the cross product, because that's a little cross, a little multiplication cross. Make sure you understand the 2 are different. Why are the 2 different? Hey, I've got 2 vectors. I'm doing an operation on those 2 vectors. And what do I get with the dot product? I get a scalar, not a vector. Do you understand that? It's a scalar, not a vector. It is a single value that you'll get out of this one. But the cross product, if I put 2 vectors through the cross product, what happens? I get a new vector. And what do we know about that vector? That vector that I get out of R and S will be mutually perpendicular to both R and S. And you can use your right-hand rule. For those who know the right-hand rule from physics, I teach it in stage 2 physics, or it is also taught in specialists as well, the right-hand rule, to determine the direction of new vector R times, R cross product S. But, okay, what we're going to go through now is the algorithm, how to do this. Okay, so R dot S. Now, so this is question 3, part 1 we're doing. All right, so okay. Sorry, I'm going to write out the full thing. Bear with me. Not going to take that long. I just want to write this out so we know what we're doing. We're doing the dot product of these 2. So you can see what I'm doing with the numbers. If you are already familiar with this, that's cool. If you're not, if this is the first time you've seen the dot product, like you just stumbled into this without knowing what on earth is going on. Hi, how you doing? They call me the woolly mammoth now. I do math and physics. Good to meet you. Okay, so we're doing the dot product. So hi, if you haven't done the dot product again, watch this. Okay, take your x values, multiply them, plus take your y values, multiply them, take your z values, multiply your y values. All right, that's 2. Sorry, I forgot the addition. I stuffed that up just there. Take your x values, multiply them, plus take your y values, multiply them, plus take your z values, careful, -4 times +2. And so add those all up when you work them all out. So 3 plus 0 minus 8. Now minus 8, because it's -4 times 2, plus -8 is -8. Happy? Good. I hope so. -5 is the answer for that. Okay. Are we all happy with the dot product? All right, so I'm going to write that down on a piece of paper here because otherwise I will forget that. I know this is going to be done again somewhere. There's a reason why they're getting us to do this. I could be wrong. It could just be arbitrary math, but I have a strong feeling that you're going to see the result of that again. All right, so I've written that down. That was -5 for the dot product. Okay, now let's write out the cross product. All right, now the things you need to understand about the cross product. You need to understand 3x3 systems of linear equations. If you haven't been taught this in math studies, you're at a bit of a disadvantage because you need the 3x3 determinant. I will show you how this works, and I'll explain it as best I can. But you need to, if you haven't done this, if you haven't done the cross product before, and if you haven't done linear algebra / matrices with 3x3 determinants, this is going to look like gobbledygook. But just follow closely, and we'll see how we go. All right. First of all, let's set up the matrix that we're going to use to do this. All right, I'm going to put it here. Now the matrix, the top line will be I, J, K. Now what are I, J, K? Now you should remember this. I've been through it today. What's I, J, K? They're the direction vectors of X, Y, and Z with length of 1 unit. Correct? Yes. Good. You all know what I, J, and K are. Excellent. So I should write vector symbols over them, but I'm just that's just going to make things look messy. You put a little squiggle underneath them, or just make them bold so they look like vectors. Whatever you want to do, just be aware that that's what they are. Okay. Now what comes? So we're setting up a matrix. So that was our first row, and you notice I've made the matrix lines, the determinant lines. Are far longer than that row. So there's obviously going to be more rows. So what comes next, Eric? Okay, what comes next is 3, 0, neg 4. Happy? That is our R. So R comes to 4S. R comes to 4S. R cross S. So you write your R next. Guess what comes after that? No, it's not Santa Claus. It's 1, 2, 2. That's S. Okay. We're all happy? I hope so. Okay, that's how you set up the 3x3 determinant. Now we have to evaluate that. Okay, let me just show you how you do that. First of all, okay, we're going to have 3 determinant, 2x2 determinants. Now let me show you how that works. Basically, the rule is go down to the right. Okay, go down to the right. What do we get? We get 0. Let's put that in. Okay, now you put everything that fills up the spaces where the rest of it should go. So what's this way? What's on the right of 0? -4. What's below 0? 2. What's below that to the right? What's to the right of 2? What's below -4? Another 2. Does that make sense? Well, let's watch this way. We'll do another one. In fact, we're going to do another 2. Okay, J, that's the J one. You might have been taught a different way to do this as well, one that has a negative in the middle. I don't teach that way. I was taught that way, but I teach this way because I think this is easier. Okay, now, what's down to the right of J? -4. Okay, what's below that? 2. What's to the right of -4? Nothing. Hang on. Then what do we put there? Okay, well, you go into the right, but then you've got to loop back over here. Does that make sense? It's the only thing you can do. You've got to loop back to the other side. Okay, so it is 3 and 1. Okay, I hope that wasn't too confusing. So let's think about K. So that's a funny looking plus sign, but if I press Control Z, it's going to just spit chips. So you're going to have to do that plus sign. Okay, down to the right, what do we find? Absolutely nothing. There's nothing there. What do you think we do? Wrap back around this way. You're correct. That's exactly what we do. Well done. Good thinking. Okay, So what happens? 3. Okay, tell me what the rest are. Correct? Correct? Correct. And that's your K. Special K. There we go. Fix the K. Okay. Now, 2x2 determinants have their own little rule. Basically, if you think of them this way, I'm just going to change colors here, and you can take note of this. I'll write out the rule for this because it won't take nearly as long as the rule for other determinant, like the 3x3 determinant. Once you got the concept of the 2x2 determinant, the next part should be pretty simple. Okay, 2x2 determinant will be A, D minus B, C. As you see how I wrote it there. Did you get that? I've set up a 2x2 determinant of A, B, C, D, and the resulting method to find the determinant is to times the diagonals and subtract them. The leading diagonal is AD, but then you subtract the next diagonal of BC. There are no other diagonals. You can change the direction, like you say C to B instead of B to C. But that's the same thing, isn't it? Does that make sense? Yeah, DA is the same as AD. Well, it is true for real numbers. It's not true for the cross product to change the direction, and we'll talk about that probably later on. That's probably going to show up somewhere. But when you multiply just ordinary real numbers, like you think, okay, I've got minus 1.5 times by 7. What's that? Just do that in your head. So what do you got? You got 10.5, or minus 10.5. I think I shouldn't have picked numbers like that. Yeah, that's 0.5 is 0.5 of 7 is 3.5, and 1 is 7. Yeah, it's minus 10.5. Correct. Yes. And if you change the order, it is still minus 10.5. Okay, I'll do another example just in my head. Let's just say 2 times negative 8. 2 times negative 8, positive times negative is negative. 2 times 8 is 16. Negative 16. Swap the order. Negative 8 times 2. Negative times positive is still negative. 8 times 2 is still 16. Negative 16. Both ways is cool. Now, all right, so that's true for real numbers, but don't get confused. It's not true for all multiplication applications in different forms of algebra. And I'm just going to get rid of this. Because it's taking up space, and I mean you can just go back into where it was in the video and look at it again. I'm going to carry this out from memory because obviously I've done this many times. Okay, that's cool. All right, so back to my white pen. I might even try something a little bit different. It has to be bright. Let's do this lovely little blue. Okay, now so let's work this out. Now, I is the x direction, so let's put our x, the first bracket in there. Now, careful with all the negatives. There's going to be a lot of negatives floating around from the process. Okay, that's the first operation. 0 times 2 minus negative 4 times 2. I hope that makes sense. If not, let's just keep going. And see if you can pick this up. If you find any mistakes, again, I will address them. I will acknowledge them. I'm not going to make another video with all of this in it. All right, so minus 4 times 1 minus 3, that's positive 3. So let me just write that minus, it's a little bit obvious. Redo that. Minus 3 times 1, comma. That's right. Yep. Okay, that's the J. And now we've got the K. So I have to look over to the side a bit. I'm obstructing my microphone doing this. All right, let me just Control Z that. Back to pen. Okay, so hopefully you can still hear me as I'm writing this out. 3 times 2 minus 0 times 1. Okay, now I know that the zeros are superfluous in multiplication, but I'm including them so you can, if you're following this, you can understand where all the digits went when I did this. So I've deleted the formula I wrote out for the 2x2 determinant, but hopefully that makes sense how I've just gone and entered those in terms of the context of what I just showed you with that algebraic statement to do the 2x2 determinant. A times D, so let me just say that. So I've got A times D minus B times C. A times D minus B times C. A times D minus B times C. That makes sense? I hope so. Regardless, we're moving on. Let's just solve this. 2 times 0 is 0 minus -4 times 2. All right, and so minus 1 times -4 is positive 4 times 2 is 8. Cool? Good. Minus 4 times 1 is -4. Minus 3 times 1 is -3. Let me just double check that. No, I wrote one of those wrong. That's 2. Apologies, that was actually 2. If you picked up on that mistake, well done. So yeah, it's -4 times 1 and 3 times 2. I hope I have transcribed all the numbers down correctly from the 3x3. I think I have. Yeah, I am just double checking it now. Yes, they're all correct. The last line in pure in white, which I kind of just crossed out with the blues, that line is correct. Okay, so this line now has been updated to being correct. So it's now that operation should be correct. -4 minus 6 is -10. I'll double check this with the solutions in a minute. Make sure I haven't made a massive error somewhere. Okay, positive 3 times 2 minus 0 times 1. So that 0 times 1 is still 0. That's 6. Okay, 8, I'm going to write this down, 8, -10, 6. I'm just going to be brave and think that that's actually correct. Let's have a look down here. Now, what question was that again? That was question 3, part 1 with the cross product. Yes, I'm correct now. You can see it there, 8, -10, 6. That's correct. Cool. All right, so yeah, again, I feel vindicated. I've managed to fix my own mistake. So yeah, well done to me. Okay, delete and cast my lasso nice and big. Come on, you little doggies. Okay. Alrighty. So that was that. Okay, that was question 3, part 1. Apologies, I am taking my time with these. I just want to make sure everyone understands. So I'm making this for a broad audience. My students should have mastered most of this stuff. However, I know some of them have been, there's a number of people who have been absent from a lot of time. And a number of people who basically there's some people who have had a hard time with this particular chapter. So I'm taking my time working this stuff out. Okay, now let's carry on. 3, part 2. Find AB. Well, let's get our pen up and running. Let's make a different color. Okay. All right. I'm going to be. I've done light blue. I'm going to be. I want to be green. Okay. I'm green for the moment. Okay. A to B. Hopefully you can see that well enough. Again, I'm going to have a look over these in on my iPad and other devices to see how this turns out. Hopefully the microphone levels are good because I've invested a fair bit in that. Okay, but let's get on with it. Okay, I'm going to use the same techniques I used for that previous question. I'm going to do it the short way. 1 to 4 is a positive movement of 3. 2 to 2 hasn't moved at all. 0 to -4 is a negative movement of 4. Okay, I hope you're all happy with that. Guess what? We've seen that already. Over here, look over here, the left, that is R. Well, whoop-de-doo. I had a feeling that this was going to show up again. Now, I haven't done this test since about this time last year. So, probably a little bit earlier. But when you've been doing these tests, when you've been giving these kind of practice tests over and over again for several years, things stick in your head. Like I use the same, like previous year's exams to instruct students who are preparing for exams. And most of the questions, when I write out the answer, I know if I've done them wrong and right because I remember the answer. I remember like you look at a question, you point to a question and say, what's the answer to this? I can't tell you the number off the top of my head, but when I work it out, when I get to the end, I know whether that is correct or incorrect based off the familiarity of it, if that makes any sense at all. Okay, but I'm wasting time again, so let's crack on. I hope that made some sense. Okay, part 2B, determine the size of angle C to A to B. All right, now A is in the middle. Okay, so let's think about it this way. I'm just going to draw a little diagram which includes the points C and A and B. And we're talking about this angle in here, aren't we? CAB. That's angle CAB. And I'm going to call that theta. That's my name. That's my name for it. That's I'm not being very original. I know all angles are called theta or phi, or maybe A or alpha or beta. Theta would be the most common Greek symbol used for angles. Okay. Now, okay, so what are the vectors? Okay, C to A. Okay, so we're going from C to A and we're going from B to A. So, actually, no, let's do it the other way around. Sorry, let's just change those directions. It doesn't matter, I can do this. This is going to make it a little bit easier on ourselves. It don't matter, trust me, it doesn't matter. Okay. Now, we got two vectors. One goes from A to C and one goes from A to B. Now we've got A to B. And that's equal to R. Remember we just noticed that before? Write that out again. Sorry, I'm just having trouble with doing things with my finger. Okay, AB is R. We've proved that. So the part A from 3 to A is getting you. Oh wait, we've seen that before. That question was deliberately designed to do that. You've already determined vectors from single points before, so you're not really getting any marks from that. Maybe it might be a 1 mark there, but its main purpose is to get you to, hey, notice me, I'm a vector you've already seen before. So yeah, just why don't you go find my friends? Let's go have a look for it. Let's go look for vector R's friends. Now, vector R's friends lie somewhere in the direction of A to C. Let's have a think about that. What's A to C? Have a look in the numbers. 3 to 2, 2 to 4, 0 to 2. Let's work that out. 1 to 2 is 1 in the positive. 2 to 4 is 2 in the positive. 0 to 2 is 2 in the positive. Who is AB's friend AC? Or AC is S. You see that? AB is R, AC is S. They're good buddies. They're R and S. They're right next to each other. They're always next to each other. RS. They get stuck between Q and T. Yeah, the two buddies. Q is a little bit queer and T is a little bit tiresome. You don't want to talk about W. He's a little bit unusual, if you follow my meaning. A bit weird. Okay, look, I'll stop making stupid jokes. Okay, look, we discovered what those are. Now, why are those important? Well, those are two vectors that make the angle, aren't they? So let's have a think about now, how do we find relationships between angles? There's a couple ways to do it. There's one that involves a dot product and one that involves the cross product. Now, I'm going to tell you the one that involves the dot product because that's going to be far easier. Now, apologies. I'm pretty sure I've done this from memory. R dot S equals length R, length S times cosine of angle between them. Okay. You happy with that? Now, sorry, I'm just remembering if I apply one thing or not. I'm going to apply one more thing to that formula, and I'm going to carry out that formula, and I'm not going to check it until I'm done, because I know what the connection will be. Okay, I'm putting one more thing on that formula. There, a modulus symbol. Why did I put the modulus symbol in there? Well, if I divide now, RS we already figured out, didn't we? That was part one. That was the first thing we did in part one. It was the dot product of R and S. That is -5. Now, why is that important? Well, length R and length S separately will be positives individually. And if I isolate cosine theta, so let me just write the equation for that. Cosine theta equals, all right, R dot S over length R, length S. Now, imagine if I didn't put that modulus over the top. Now, I've dropped the vector symbols as well. I hope you forgive me for that, but I'm running out a little bit of space. I don't want to delete this necessarily. I might delete something in a minute, and I'll just write up the top. Or I might scroll down, because I can do that too. I just remembered that. Okay, but for now, I'm just going to leave it like that. Okay, now, if I don't put the modulus around there, I'll have -5 on the top and positive numbers on the bottom. Now, there's nothing wrong with that, and I'll explain why, but I made it a decision to put the modulus in. Okay, and it has to do with a confusion in the way people teach how to use cosine and sine. Now, for those who have done specialist maths, who've done like the first few chapters in the trig stuff, you should know that sine is positive in the first and second quadrants. So your acute angles will return positives and your obtuse angles will return positives. And it's negative of everything up to a full cycle there. So everything past 180 up to and before, or up to and past 180, so 180 and before 360, those are all negative values if you put them into sine. However, cosine is positive in the first quadrant, but then negative in the second quadrant. So what that means in terms of this is if I put it in this way, I'll get an answer that is greater than 90. But when you usually solve for these questions, you want the acute angle. If I put the modulus in, which I'm going to add now, this should return the acute angle. So let's have a look at that, and we'll see what happens. The acute angle, so that value there is 5, because the dot product was -5. So now I'll put the modulus in. The modulus changes negatives to positives. Okay, but it's the modulus of R and modulus of S. Now what they do is they will find the lengths. Okay, so I'm going to put the lengths here. Sorry, you don't know where I'm pointing, but I'll start writing something. Okay, separately, mod R equals, actually no, let's put them below. Let's put them below. I said I would, so let's do it. Mod R, now I have to go up and see what my R was. Okay, R is 304. Okay, now I'm just going to shorthand that. That's 3 squared plus -4 squared. Okay, that's 9 and 16 is 25, and that's 5. You happy with that? 9 plus 16 is 25. 25 is the square of 5, so the square root is 5. Okay. So apologies for doing this quickly, but I know I'm kind of pressed with, as I've said, I'm pressed with time. Just want to get this done and move on to other questions, and then finish up, and then have a nice sleep. Okay, so let's do this one. All right, S is 122. So 1 squared plus 2 squared plus 2 squared. What's that? Well, that's 1 plus 4 plus 4 is 9. And what's the root square root of 9? 3. Brilliant. Isn't that nice? Isn't that nice and easy? Okay. So on the bottom goes 5 and times 3, because it's R times S on the bottom. Can you see that? R times S, with my little cursor wiggling around there. Cosine theta equals, so let me write that down. I'll cancel the 5s. Let's write that out. Okay, cosine theta equals 1/3. All right, you happy with that? Now, if I did leave the modulus out, it would read -1/3, because there was that -5 on the top. With 5, positive 5 would still be in the bottom, and 3 would still be in the bottom. So it would end up being -1/3. Now, pardon me, I forgot to bring my graphics calculator. I can't do non-standard inverse cosines in my head. That's something. Yeah, that's a talent. That would be extremely difficult. Okay, bear with me. I bet you're all surprised that I haven't done anything on the calculator yet. I'm not. I'm a bit arrogant that way. I just I don't like. I like doing things in my head, and I, as you see, I make mistakes. Okay, the inverse cosine of 1/3 is 70.5 degrees. Now, if you're doing specialist, you might also put that in radians. You might have your calculator set for radians. Just be aware whatever your calculator is in. I've just done that in degrees, so 70.53 degrees. Okay, now I'll change that to radians, and I'll just tell you what I get. Okay, in radians, that's 1.23 radians. So we'll check that in a minute. Now, just for the sake of completion's sake, I'm gonna put in -1 on 3 and see what I get. Okay, now I want to read that in degrees. Now I've got 1.91 in radians. But I want to know what that is in degrees, because that makes more sense to me in degrees. It's 109.47 degrees. Now, that is obtuse. Now, let's have a look at what the answers say. Either of those would probably be interpreted as correct. I feel the first one is more correct, just out of habit. But either of those answers would be valid correct, unless it particularly asked for an acute or obtuse angle, and this one did not. I'll go back and check that in a minute. All right, so part 2. Let's have a look at, okay, so here's the question. Here's the dot product. There's a cross product. Where's the rest of it? What's the rest of the question? Oh, there it is. Okay, angle, yeah, 109. Okay, they did it that way, sorry. Yeah, I was. Now, let's actually read the question again. Determine the size of angle C to A to B. That's arbitrary. I'll put a little asterisk on that, just for the sake of this. That is arbitrary. It didn't ask for the acute angle, and it didn't ask for the obtuse angle. Now, in general, and I'll make this as a general statement, in general, if it asks you for an angle, you always go for the smallest angle. So the obtuse angle is, let me draw this on the little drawing I've done here. That's that. Now, I know I've drawn my angle is actually way too small for what it is. I just drew two lines joining, essentially, with a rather small acute angle. So that my angle there that I've drawn, that the little one, is probably a little bit greater than 45 degrees. It's probably 50, which actually isn't that far off my my answer here of 70. However, this one looks huge. Actually, sorry, no, I've done it wrong. No, that can't be right. That can't be right. All right, so it's continuing the lines. Sorry, I know what they're talking about. Okay, sorry. Sorry, this is the angle they're talking about. There you go. As I've drawn it there, that's phi and that's theta. Okay, that's it. You see that other angle I've drawn there? That one that goes, yeah, that one there. That's the angle. Does that look confusing? I imagine it does. Okay, now, so that's the obtuse angle you get from the negative cosine. So I'm going to put that in for completion's sake. So as I said, I always, if I make a mistake, and I don't even think this is a mistake, I stand by that answer in the way the question was written. And I explained why I put the modulus in. I spent a fair bit of detail explaining why that is. So, okay. So and we are talking about minus 1/3 now. Minus 1/3 has an approximate angle of 109.47 degrees. Okay, can we understand the difference here? What you should do, add up those two numbers, 70.53, 109.47. What do you get? I'll just have a little sip. Did you say 180? Well, you are correct. Well done. Yeah. So, yeah. Okay. All right. Now, to save face, I'm going to, now that everyone understands that, I'm going to get rid of all this. All that's going to be gone. And, okay. So you guys, you understand my mistakes. And I hope you understand my reasoning is more important. If you understand what I'm doing, you understand why I did what I did, unless it's a kind of a little trivial me writing down a number wrong mistake. Okay, so I hope you appreciate the kind of the extra thought I'm putting into these questions, even if I'm doing kind of what would be my own test differently from the solutions I've got. Okay, now, one last thing we need to do for this question. Let me just get the questions together properly. There we go, part C. Now, this one I won't stuff up because this one's pretty, although it needs the cross product, it is very simple. Pardon me. Okay, now the area of a triangle by using vectors. I'll give you this formula. Half modulus cross product of, now it doesn't actually matter which one it is. So long as you've got two vectors coming off a single point. Now, we wrote them down. A to B was R, and A to C was S? Yes. Okay. It doesn't really matter which pair of vectors you pick from the three coordinate points. What matters is that the two vectors must come off a single point. I think that's one thing that is important. So you can't do, you can swap one of the vector directions around. Actually, you probably can swap both. In other words, I could write BA times AC, and because of the modulus, that still works, because they'll cancel the negative change of direction. If you swap both, it will swap both directions, so thereby you're back to where you start. So if I wrote vector BA times vector CA, that would be exactly the same, I would imagine. Yeah, it would, because I'll be canceling. I can just think about the change would just be two negatives canceling. Negative times negative is positive 1. What other ways can I stuff this up? Because I've been stuffing up a few things tonight. Let's talk about the ways we can stuff this question up. Okay, how can I stuff it up? All right, well, Okay, instead, what if I had AB times BC? That's fine. Now, I should have written it AB. Sorry, just for the sake of clarity, I should, if I change the AC to be BC, I should probably do the cross product as BA times BC. But as I said, the modulus corrects for that. So that's fine. Actually, this is pretty much idiot proof. I'm trying to think of ways to stuff up the question and I can't think of it. So that must be very good. The modulus really takes care of a lot of things in this. Of course, it's to make sure you do the cross product, not some other operation like the scalar product or anything else. And make sure you apply the half afterwards. So the modulus really does take care of everything. Okay, so now I'm going to, now I'm just going to rephrase that in terms of R and S. Oops, let's just fix that up. And okay, happy with that? I hope so. Okay, now why did I do that? Well, we've already know what cross product RS is. Let's put that in. Just a reminder, that is 8, -10, and +6. Okay, so now we have to take the modulus of that. Now, the modulus is the distance formula acting on vectors. So let's take that distance formula and just apply that. So 1/2 times square root of 8 squared plus bracket 10 squared plus bracket 6. That bracket isn't entirely necessary. Neither is putting 1 around the 8, just the 10. Okay, so what do we got? 1/2 times square root. Okay, 64, 100. And what's 6 squared? Did I hear 36? You are correct, whoever said that. Okay. All right, well, what's that added up? Okay, 64 plus 36 is 100 plus another 100. That's a plus. Those are pluses. So what have we got? Say it with me. Square root of 200. All right. Scrolling down. Equals. Simplify that. All right. Square root of 200 can be broken down into the square root of 2 and the square root of 100. What can the square root of 100 give us? Well, that gives us 10. Half of 10 is 5. Now, I've been forgetting to do this, units, like putting that thing in for things like area and distance. All distances are units unless otherwise stated. All areas are units squared unless otherwise stated. All right, but I hope you understand my working with surds. If you don't understand surds, it's a separate thing. But the square root of, again, just one more time, square root of 100 is 10. 1/2 times 10 is 5. So we have 5 times root 2. The root 2 is still multiplied in there. Okay, so that was done nice and quick. I just explained the ways in which you could do that right. And just about every way you approach that question, so long as you use the vectors, you could stuff up writing the vectors out. But yeah, so we had the vectors. So there was actually, that was kind of idiot proof that that formula is really, if you know how to do the operations correctly, you can't get that too far wrong. So that's kind of a good note for everyone. Okay, moving on. Question 4. Okay, we've got a triangle. Consider a triangle formed by A, B, and C as shown in diagram below. Okay, we can see that here. See everyone see that diagram? Yep. Yay. Okay. As shown in diagram below, X is a point on the side of AB. Show that AC is perpendicular to AB. Now, how do you show perpendicularity? Come on, someone tell me. How do you show perpendicularity? I'm going to pick a different pen while you decide. Something about the dot product equaling 0? Yeah, I think you got it. Yep, okay. How do you show So if AC is perpendicular, so we got to prove AB dot B. No, was it AC or BC? AC. Well, it doesn't matter what order, but so long as but the two vectors are AC and AB. Prove AB AC dot equals 0. Okay, that's what we got to do. All right, so let's work out what AB and AC are. And this will be quite obvious because the points are all given, so this is not going to be too difficult. Now, so again, I'm going to do this shorthand. So you've seen me do this a few times already. You should all be pros at this. 0 to 5 is 5. 0 to -5 is -5. 1 to 11 is 10. Done. Okay, A to C. So I just did A to B. A to C. 0, 0, 0, 1. Sorry, 0, 0, 1, 2. Values of C are 6 to -1. Okay, the transitions. 0 to 6 is 6. 0 to 2 is 2. 1 to -1 is -2. All right. So was everyone more or less happy with that? I hope so. Try it for yourself if you're not sure. Just pause the video, do it for yourself, prove it to yourself. I'll know in a minute if I've done it wrong because what I'm going to do next won't work. But I'm pretty confident I can see the numbers and just the way the numbers are looking to me at the minute tells me that this is probably going to work. Have a quick look at the numbers. Five and six. 5 and 6. 5 and 2. Yep, I can see that. I'm seeing it ahead of time. I'm just confirming in my head what I'm going to put down right now. Okay, let's do the dot product. So reminder, take your x values, multiply them, plus multiplication of the y values, -5 times 2, plus there's my plus sign. There we go. There's the messiest plus sign ever. There we go. But you know what I'm trying to go for here. 10 times -2. As I said, I will be improving my quality in doing these. I'm investing in I've invested in a fair bit of software so far and hardware. And I've got a few things coming in the post, which I'm going to try out in the next few videos. So look forward to that stuff. Okay, but anyway, let's just solve this. 5 times 6 is 30. Happy with that? -5 times 2 is -10. -10 times 2 is -20. Well, would you look at that? 30 minus 10 minus 20 is what? Say it with me. 0. Implies that perpendicular. That's a relationship of the dot product with 0. If the dot product of two vectors is equal to 0, that implies the two vectors are perpendicular, and vice versa. If the two vectors are perpendicular, their dot product should be equal to 0. So if whenever you are asked to prove something is perpendicular using vectors, think about dot product equals 0. That should always come up in your thought process. Dot product equals 0. Just keeps thinking that. And think about also the other rules as well. As a reminder, parallelism. How do you prove parallelism? If A and B are parallel or collinear, what's the key thing you're looking for in terms of the directions being the same? Vector A equals scalar K times vector B. So you always should set that up. Okay, how do you prove what's another one that's simple but important? Okay. Okay, so I've talked about collinear was also sharing this a common point. So you had like a point of A that you shared, or whatever you happen to call it, and also being parallel. That was the condition for collinearity. What other things you have to prove? So we're talking about perpendicularity, parallelism. Angles was associated with the dot product. Dot product equals individual lengths times cosine theta. Rearrange that. You got all the area formulas involved and volume formulas involved in the cross product. There's a bunch of other proofs. There's also proofs of other proofs of collinearity, proofs of coplanarism, and other things as well. But yeah, consult your textbook for those. I'm trying to think of another simple one that's important, but it's eluding me at the minute. Maybe I've covered them all with what I've said so far. Okay, let's group you all up. Actually, was I meant to do something more of this? Well, that's part one. Sorry, I'm on question 4. I thought I was finishing off question 3. No, I'm definitely on question 4. Okay, so I've shown for part 1. Okay, find the coordinates of x if ax equals 3 to axb. Okay. Okay, now part 2. So let's get back into it. Question 4, part 2. How do you express as a vector a position? Did you use the word position vector? Well, then you're correct. Okay, what's the position vector of x? It is OX vector. We're going to find OX. Now, when you set up a vector method, you've got to use the vectors you've got on hand with the points that you know. Where possible, sometimes you may have labeled vectors that they give you, like they tell you, okay, this is vector A, this is vector B. Write a statement in terms of those, something to that effect, where you would use those. And we'll see an example of that probably later on, maybe not, maybe in the next test. Look, I'm not reading too far ahead of the minute. I don't want to, because I like to a little bit surprised with what I'm doing. Okay, but anyway, okay, OX. Now we want to find that. Now, when you finding vectors, you take paths you know. Okay, what are the paths that we know? Well, we know the positions of A, B, and C, and we know there's a relationship between the dot products of some of these vectors. Okay, and we know that AX equals 3/2 of XB. Okay, that's what they gave us. That's a little hint they gave us. Now, we're going to start from O, and we're going to go somewhere else. Let's go to A. Hey, we know that because we've got the coordinates of A. And remember, position vectors are the coordinates. OA, I'm just going to write this here, over here, equals the coordinates. Because think about it. It is O, which is 0, 0, 0, to A, which is 0, 0, 1. So what have we traveled? 1 unit in the Z direction only. Okay, that's how position vectors work in terms of writing them. Okay, so we've got OA. Now, we still got to go, we've gone from O to A, but now we've got to end up at X. All right, now AX, I don't know what AX is. I don't know what that is. But there's a relationship there. Why did I write AX? Well, I've got to travel from A to something. Now, I could have done that a little bit longer. I could have gone from A to B, and I will use that in a minute, and then from B to X. But I'm going to write it that way for the time being. And it would make sense in a minute. So I could have done it the other way, and that probably would be just as much work. Essentially, I need to write a statement that will get me from A to X in terms of things that we already know. All right, so I'm still going to keep OA as OA, but what is AX? AX is A B plus B X. So I'm actually traveling past X to B, and then from B to X. All right. Now, was that actually? I'm thinking, was that a valid? Is that going to be useful? Sorry, let me give you that a little bit of thought. Okay, now the dealio is with this. Do you see what I just circled there? 4 part 2, find the coordinates now. A to X equals 3/2 XB. All right, so let's actually look at that in terms of ratio. Pardon me. Okay, A to X is this here, and then we've got X to B is that. Now, they have a ratio of 2 to 3, I think. 3 lots of XB is 2 lots of BX or AX. Hang on. I've stuffed it up. Sorry. What am I doing? What am I doing? Okay, XB. No, that was right. I drew A to X and I drew X to B. Well, actually, hang on. I drew it the wrong direction. The arrows went in the wrong direction. That's what I was confused about. There we go. Okay, that's AX. And that's a 1.5 times longer because 3/2 is 1.5. 1.5 times longer than XB. Okay, so essentially that is, for every 1 unit of that is 1.5 or 3 and 2. Does that make sense? If this ratios are 3 and 2. All right, so let's talk about this in terms of ratios. Now let me just label these in 3 ways. Okay, A to X, ratio X to B, ratio. Now, watch here, AC. This is going to help a lot. That last little bit is going to help a lot with understanding what's going on with these. Okay, now 1/5 to 1, or sorry, 1.5 to 1 is the same as 3 to 2. That makes sense so far? So if you times the 2 in this equation, if you times the 2 across, it'll be 2AX equals 3XB. That's where that ratio comes from. So AX is the longer one, it is 1.5. Because you see that's, if you've got to times XB to 1.5 to match the length of AX, they are parallel because they have an equation between the number in the middle on one side. So that's the ratio. Now think about what's the ratio in terms of that with AB. You probably are sitting there confused. Why C? Because we haven't used it yet, and that's why. No, we're doing things in terms of A and B. We went from O to A. Now we're trying to work out where to go from there. Now, what's the ratio? All right, 3 to 2 to 5. That makes sense. Sum of the other 2. That's if that's 3 and that's 2. Well, that's 5 in ratio. Sorry, that's a very squiggly. I'm getting a little bit excited about my ratios. All right, so let's go back and let's just fix this up. All right. Now, what is AX in terms of AB? Well, let's have a look at that. They're both parallel. Now, AX is 3 out of the 5. Does that make sense? 3 units out of the 5 units that AB would be. Okay? So that means AX is 3/5 of AB. All right, let's write that. And I'm doing this other bracket as well, but let's keep it in there for now. 3/5 of AB. Okay, so yeah, I didn't need to do much more moving around. All right, now we've got enough there. That is enough to solve for X. So let's go and do that. There are many other ways you could have moved these around and get the same answer. But I will check the answer for this because I had a little bit of fooling around to get there. I hope you guys understand what my logic was behind that. Okay, now we've got AB is 5 minus 5, 10. Sorry, 5 minus 5, 10. Okay, plus. All right. Put a bracket in there for OA. OA, well, actually, OA is easy. It's 1, 0, 0. I'm sorry, I'm reading it backwards because I'm writing it backwards. It's 0, 0, 1. Yeah, you see that when I've read it on the screen. I read it backwards because I read it backwards. Okay, hope you weren't confused by that. All right, that's easy. All right, let's finish this off. Let's get this done. All right, excuse me while I just do this in my head. 0 plus 3/5 of 5 is 3. 0 plus 3/5 of -5 is -3. 1 plus 3/5 of 10 is 7. Double check that. 1 plus 10, 30 divided by 5 is 6 plus 1 is 7. Correct. Okay, 3 minus 3 and 7. Okay, that is the coordinates of X. That is OX as position vector. So thereby X is, just for completeness sake, sorry, and I've read alpha. Okay, well, that's OX, so we already know that. Let's just write out X. Now, I'm just being a little bit particular. I want to make this distinction because I always want to make this point. Round brackets denote coordinate position. Square brackets denote vectors, even position vectors. Position vectors are always O to something else. And O by definition is the origin, 0, 0, 0, unless stated otherwise in the question. Just be careful. They shouldn't do that. That's naughty. Should always keep O to be your origin. If you've got a question that's designed that way, just go have a conversation with your teacher and say, O should be the origin, sir or ma'am. Should always be that. Don't use O. Don't use the letter O for anything else but the origin. So don't get yourself in trouble over it. But just give them a kind word of advice. That's my suggestion. Okay. Sorry. So I'm doing. Sorry. What question am I looking at? I'm looking up. Oops. Sorry. I'm drawing. I need my hand tool. There we go. What question was this? I've lost the number. Oh, there they are. Sorry, they disappeared briefly. All right, question 4, part 2. Three negative 3 is 7. Now they did it a very much longer way. You see what they did? Let's have a just quick look at what they did. See, I'll just have a look here. So they got how did they go? AX equals that, or AX equals that. Okay, fair enough. Okay, so I think they've said X is unknown, X, Y, Z. Is that what they're doing? Yeah, what they've done is set up. Okay, I recognize this now because this is what let me just put the pen out Let me explain what they've done. So this is an alternative way to do it that's actually a little bit more convoluted. So I'm kind of pleased as that my way was a lot more efficient, even though I spent a long time explaining it. This is AX, because X is, the coordinate X is curly bracket parentheses, X, comma, Y, comma, Z. And A is 0, 0, 1. So AX is final take initial, X, comma, Y, comma, Z take 1. That makes sense? Okay, that's how they've done it. And then there's actually not a lot of vector, not a lot of vector kind of positioning took place there. It's just they equated that straight away to 3 halves XB, or 3/5 AB, which is kind of what I did. I had to spend a long time explaining that though. And then I got the equation for that. And you see they've constructed XB in terms of X, which is X, Y, Z, and B, which is it 5, take 5, 11, or is it minus 5, positive 5, negative 11? I think it's the former, not the latter. Regardless, basically what they've done next after that, what's below that is a bunch of equations involving solving for X, Y, and Z. So yeah, I think that was, I think my way's better. What do you guys reckon? Have a think about it. Which way do you like better? Which way made more sense? I think my way is better. That's just my opinion. Okay, I have to do one more thing with this. Area, find a ratio of area AXC to area ABC. Think about that. What's the easiest way to go about doing that? I found position X, so let me write that down because I know it's going to be important. AXC, A to X to C, and A to B to C is obviously larger. They're both right angled. ABC, AXC. Now, I'm doing this in my head purely for the moment. So let me just delete all that stuff. I've written down what X is. Oops, I did a Control Z. Let me just clear. I'm just going to clear everything. And my lasso tool. Because I've got an idea of how I'm going to approach this question. You notice I'm doing this a lot of this. The way I approach questions is I'll think about independently. I'm trying to think the way you guys think in terms of okay, you're presented with this question, you read it a couple of times, and you've got to come up with, okay, what do I do? And you might go look at your equation sheet or stuff like that. I'm not doing that part because I've memorized all the equations for the most part. I obviously I don't remember half of the trig ones because there's a lot of them. Like if you've done the trig stuff, you know what I'm talking about. Oops, there's a lot of stuff there. And it's clear, it's clean. Isn't that nice? We've got a nice clean page, mostly. Okay, now, let me explain how I'm thinking through this one. I'm going to give you a short answer and a long answer. Actually, no, I'm going to give you a short answer and I'm going to explain how we might approach the long answer. Now, the short answer is, okay, now that was in ratio of 3 to 2, yes? Cool, we remember that. It's given by this. Okay, let's think about this. So we got the triangle of AXC. Okay, then we've got the triangle of ABC. That one there. Yeah? Okay. Now, you can construct this triangle. So this triangle I could construct using this. Actually, I'm going to do it AC times AB. Yes? That's how we did the area of the triangle. Now, what about the other one? Well, let's think about the other one. Let's go back to our orange. And let's think about this one. How do we do this one? 1/2 of AC, still AC, times AX. That makes sense? Yeah, because that length is AX, not AB. What's the dealio with that? Well, AX and AB. Let's have a think about those. We already did this. AX is 3/5 of AB. Or 3/5 times AB. That's how we wrote it before. Okay. So there's that. So I can take that ratio out of that, and it should be the same thing otherwise. Is that going to work? Let me explain. Well, I just have a little, I've just let my brain just kind of sync up with what I just said. Sorry, I do that. You might have noticed I get quite absent-minded from time to time. Okay, let me explain the long way. The long way is actually you go and literally work these out. The long way is you go work this out. You have X, so you can do that. Now, this is not, that is a very lengthy, because we've already done a cross product, so we've already been tested on that. We've already calculated an area of a triangle in 3-part 2C. So we've already done both of those operations separately. Once again, will we really have to do two cross products and 2 areas of triangles, even though we've already been marked on it once before? No. So you shouldn't have to do this. That is an option if you feel you need to. If you can't think of it any other way, just go crunch the numbers, come out with an answer, and look at the ratios. But this ought to work in this way. So you take your 3/5 out, and does that mean that the first area and that area, is that in ratio of 3:5? So which one's the bigger one? This one's the bigger one. So is that the 5 and that's the 3? I think it is. Let me just give it a little bit more thought. I'm actually mostly happy with that answer, but we'll check it in a minute. I'm being incredibly lazy with my rationale for that last bit. But you can see I'm basing it off this. All right, so if I times the 5 across, it'll be 5AX equals 3AB. Now, if you take that out, so essentially we make it the same thing. We call it like, all right, I'll write it like this. I'm writing over here. 5AX equals 3AB. Now they're parallel because they form this equation, and also they're on the same line. You can see that, but yeah, this is obvious. They form the AB is a line that forms a triangle, so thereby must be straight along and including the point of X. Okay, now let's call that something else entirely. Let's call that vector little a. Why not? Just for the hell of it. Okay, then what you do is you replace the ones in here. So AX is going, 5AX. Oh, I've stuffed this up. Okay, no, sorry, I've got to divide both things by, I've got to divide by both numbers, actually. That's going to be awkward. No, let's rethink this. Sorry, redo it. Okay, let's just do it like this. AX. So I'm just going to replace the AX bit with 3/5 AB. Now you notice they both have ABs instead of that one having an AX. That's just easier that way. Okay, and basically now I can move the 3/5 in front of that. I'm just wondering if I could just take it out of the modulus just like that, if there's some special rule that I'm missing. I think that's fine. I think I could literally write this as 1/2 times, let me just redo that again. So I'm making a mess of this. This, I'm going to write over here as 1/2. This is now going to become 1/2 AC times 3/5 AB. Now taking that out, it should read as this: 3/5 times 1/2 bracket AC times AB vectors. Okay, so basically the smaller one is 3/5 of the larger one. So that will make it ratio of 5:3. Let's go and check if that's correct. Yes, there you go. Sorry, I spent a lot of time explaining that, but I hope it pays off. Because that was just, I just did that purely in my head. I didn't calculate any vectors. I just did that from memory of the ratios. That's all I did. Just from memory of ratios, I was able to find the ratio of triangles. Now, just be careful if something happens in the process, like I had that ratio 3/5, I took that out of the modulus because that was safe to do so. Other cases, it may not be. Like if you've got a negative, or if you've got some other number, or if you're using an operation that will do something to that number, then just to be very careful with that. But I was quite comfortable, and I was wondering that myself. Is something going to happen? And I just I trusted that I'd done it right, and yes, I was correct. Okay, let's just get this together. Let's see, come to me. Let's get all the cows rustled up. Okay, move you over. Okay, so now we are done with question 4. Excellent. Let's move on. So we've got 2 more to do. 2 more questions and we're done. I'm going to take a nap after this, and I don't know, you're watching this probably during the daytime, so you do whatever you want to do. Go celebrate whatever you like to do. Okay, so moving on. Question 5, we've got 4 points in space. Okay, show that scalar triple product is for 24K. All right. Now I'm thinking just how much effort I'm going to put into this. Am I going to just go through the short way or the long way? Look, I've already shown you guys how to do vectors, like how to write the vector from A to B, how to write the vector from A to C, and how to write the vector from A to D. What I haven't shown you is the scalar triple product. It is very similar to the has a similar relationship to the cross product. In fact, you use the 3x3 determinants. But I'm going to do this in one hit, and I'll explain it. But you guys should be able to kind of understand what I'm doing. No, I'm not going to actually. That looks awful. Okay. Oh, decisions. Oh, however, let's just go back to Y and put it over here. All right. Because I just need, I'm going to take a fair bit of space with this scalar triple product and explain why. All right, now, the scalar triple product, you know what the cross product was like. It was ijk and then first vector, second vector. Now we've got 3 vectors in this. You take this whole as one whole operation, this whole A dot bracket AC cross AD bracket. That's one operation if you do it right. You can do it separately. You can do A cross D So AC cross AD, work that out, and then take that and dot product AB. However, you're wasting time if you know how to do it the short way, which is a scalar triple product. I'll explain it this way. You're going to put a 3x3 determinant. Your dot product outside one will go on the top, and then the cross product vectors will go second and third. Okay, let me explain that as I put it in. 5 goes to 1 is -4. 3 goes to 5 is +2. 2 goes to 6 is +4. What have I written there? I've written vector A to B. Okay? What is A to C? That was the one that's going to come next. That is -8, -2, 2 to +4, so +2 to +4 is 2. All right, that's that. A to D, -4. 3 to -1 is -4. And 2 to K, all right, that is K take 2. Is that confusing? Okay, now you finish at K, but you start at 2. So if you move from 0 to K, that's just K in movement. But we started at 2, so you get rid of the 2 and then go to K. I hope that helps. K minus 2 is the answer for that. That's one element sitting on its own. That's one thing. Put it in a little bracket just to make that obvious. Now, 3x3 determinant time. Let's expand this. I'm just going to jot these down. Plus. So I'm just going to scribble this down. I'll check the answer at the end and make sure I got it correct. But otherwise, it's going to spend a lot of time just working on making this look good, which I don't really want to do at this point. I just want to show you how to do it and then move on. This is a long, but it's still routine. This is just an exercise you expect to just know how to do. Like you put it on your revision notes. That's what you'd be expected to have done. I put a scalar triple product example on your revision notes. Let me just make a little bit more space. Okay. Okay, so 4 in that's -8, -2, -4, -4. All right, I hope I transcribed this correctly. If I haven't, I don't care. I'm just going to go and do this and see what happens. Okay, 4 times. Now I'm going to do a lot of this in my head. So be patient and see how you try it yourself if you want. See if you can match what I'm doing. 4 minus 2k. Plus 8. I'm doing half of this at a time, kind of. Okay, -8. Okay, minus 16 plus 8k. We'll see in a minute if I stuff this up. Okay, 4. All right. 32. 8 minus 8. Okay. 4 plus 8 is 12. Times by -4 is minus 48. $8K. 8 takes 16 is -24, times 2 is minus 48. Okay, got another minus 48 there. 2 times 8K is 16K. Oops, no, not crossing that out, sorry. Undo that slash. No. I'm getting ahead of myself. Apologies for that. Oops, get my pen back. All right, finishing off. 32 take 8 is 24. 24 times by 4 is 96. Now, sorry, you just heard me use a calculator. Yeah, I'm being a clown. I'm just trying to do a lot of this stuff in my head, trying to I just checked if 96 was double 48. It is. I could have done it in my head, but it's just it's getting late. It's 10 plus 10 where I am. I'm not used to doing maths this late unless there's something desperately required. Now, what was I meant to have got? I lost sight of that. No, that's correct. 24K. Excellent. Would you? And this is show that question, so I didn't even have to check the solutions. How about that? Just most of that was done in my head, and I'm just showing off, aren't I? Get on with it, Eric. All right, moving on. So yeah, I'm just happy I got that correct. All right, cool. Determine the points of the K, which the 4 points are coplanar. All right, the test for coplanar points. Now, if the points are coplanar, I'll explain this, and I'll just state the test. Okay, how do you make a plane? You make a plane using the cross product. The cross product makes what we call a normal vector, which is normal to a plane. Let me just draw a little sketch on this page in black. Okay, I draw a plane like this, squiggly, 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 squiggly. That's the kind of the area of the plane. Like it is infinite, but it's that's it. Okay, now what do we mean by normal vector? That normal means right angled in mathematics. So we draw a line like that. It can be any length you like, but it's at right angles to the plane. That's your normal. Now you can always make a normal by using the cross product of two vectors, so which are on the plane, which is like AC and AD. So that can equal AC times AD, or you can use any other vector which is perpendicular to the plane. Now what I mean by that is it could be the negative of that, it could be a change of length of that, it could be some combination of the last two things I just said. There are an infinite set of normal vectors to a plane. But the quickest way to get it is to take a cross product of the two vectors that lie on the plane, which is AC and AD. So I'm making my plane go through A, C, and D. What about B? Well, B was in the other one. Now, what if B lies on the plane? Okay, well, there's B. Now, A is somewhere over here. Now, if A and B are on the plane, that means that they are at right angles to N. Now, what do you think that means? Give it a little bit of time to think. I'm just going to have a swig. Okay, I'll say it again. A to B, vector A to B lies on the plane. What connection does that have to the dot product of N? Reminder again, N is perpendicular to the plane. Let me write it out for you. We got to prove that A dot N equals 0. But guess what? We've already done it. That's the test of perpendicularity. A lot of these themes come together. So I didn't even remember I don't remember all the tests, but I remember the theory behind them. And that's how I explained that. You should always write all your, write as many examples and theories and proofs of things you may not remember should always be on your revision notes. Always. But in this instance, I didn't write anything down going in on this. I'm just doing this straight from memory. All right. But in the theory, everything kind of comes back to a few concepts: perpendicularity, collinearity, parallelism. Those are the main ones. It's kind of perpendicularity and parallel, because collinearity works on the ladder and sharing a point. Everything comes back to those two things, really. And the cross product is a way to make perpendicular vectors out of the vectors you already have. Okay, so the 4 points are coplanar if this is true. So what does that mean? Well, 24k equals 0, k equals 0. Done. Now, I could have just done that 5 minutes ago, couldn't I? I could have just equated that to 0 and solved k equals 0. But I hope you guys understand. That's what I keep trying to do when I do these. And this is why I'm taking so long doing this. So this might be one of my longest streams. It's only a practice test. And I'm 1.5 questions away from finishing this. Yeah, so I found the value of k such that this is true. All right. Now, part B. Okay. What was it? Was it a tetrahedron? Tetrahedron. Sorry, my spelling is awful. Hedron. Yes. Tetrahedron. Tetrahedron is how you pronounce it properly. I've just been a bit of a goose. Okay. All right. Now the formula for that is 1/6 is the multiplication factor. You might actually, I'm scrolling back and forth with making space, and you can see the solutions there. You might have seen it in the solutions. 1/6. Now this is a volume one, so this one depends on the triple product. Now, you notice there's a bracket around this. The bracket is actually superfluous, but it does actually serve a purpose. I'll explain the purpose of the bracket. Why do we write the bracket around the cross product? Because it's actually unnecessary if you think about it. So I've written that backwards. It is important I get the order correct. Now, it was AB up the front. Now, what came next? AC and then AD? Was that right the first time? And I've written this definitely. I've written this one incorrect. Let me fix that up now. That's definitely AD, that one. Yes, AC cross AD. So I did write that correct. But maybe I got confused about what I wrote before, which was actually wrong. I wrote AB dot AC cross AB. Why would that be wrong? Well, no, that would have worked. Technically, that would have actually got me the same answer. And I'm not going to explain why. You try it for yourself. It would have actually got me 0 again, but it would have everything collapsed to 0, I think, regardless of K. Try it for yourself. Try it for yourself. That's a little thing. I just did that in my head. I might be wrong. I'm not going to check it because I'm running short on time. Okay. So let me just get this right. Now, I'll explain to you why the bracket's there. The bracket's there to serve one purpose and one purpose only. Instruction for you guys. Okay, let me explain. If I took the bracket away, what would you do? Would you do the dot product first or the cross product first? Okay, if you just say, okay, I'm reading left to right, I'll do the dot product. But remember, there's kind of like a set of rules. Think about it. If you did the dot product of AB and AC, that will result in a scalar. Can you do a scalar and then a vector product with the cross? No. You need to input 2 vectors to get the cross product to work. You say, well, maybe that just means is a number times the vector. No, but that's a different operation, even if we use a similar sign. We usually don't write the sign. We usually write, if you've got a number vector, you usually just put it next to each other like we do in algebra. Although, yes, in algebra, we sometimes say 5 times b is 5b. That's correct. But in vectors, technically, although I sometimes do it as well, technically, that is not correct. I hope that makes a bit of sense. So what does it mean? Well, if we can't do the dot product first, what other thing can we do? We must do the cross product first. If you do the cross product of these two vectors will come up with a new vector. Yes? All right, well, that's good because A and the dot product requires two vectors. We've got AB as our vector on the left-hand side, and then the resultant vector from the cross product would be the one on the right-hand side. So you can see, and then that you go through the dot product and you get a number. So you can see that's the only way this can actually be operated, if you think about it logically. So I like to explain things like that. But it's kind of like think of it like this. This is your training wheels. This is the first time you've done vector algebra with in 3 dimensions. Most likely, you might have seen it a little bit in year 11 or whatever courses you've done in the past. But you probably didn't have both the cross product and dot product going on simultaneously within the same side of an equation. I wager you have not. That's just my wager. I might be wrong. But moving on, let's finish this off. 1/6 of what? Now, this is actually meant to be equal something. I think it was 8 units cubed. So I went on a complete tangent there. But I keep saying, I hope everything I'm saying helps. 8 units cubed. I'm not going to write the S. I can't be bothered. And now, what's this? Well, that's still your 24K. All right. I'm just going to pull out my calculator again. Bugger it. 4K with no more equal sign on the left-hand side because I'm changing these up. 4K equals 8, K equals 2. Okay, done. Let's double check that. Actually, good point. I missed that. I missed that entirely. Is that really important? That went straight over my head. Yes, in general, when you unuse a modulus, you should apply plus or minus. That's why it was 2 or -2. Let's think about that logically. Does that really fit? I suppose, no, it does. For K, it does. Okay, so let's. I'm glad I checked that one. That was the first kind of real thing I picked up from the answers where I was wrong. So I haven't operated on there, and I haven't done anything. I just simplified this side to get to that, and then I just divided by 4. So it is K. K equals 2 or -2. Okay. I hope you forgive me for that mistake. Yeah, that's the first time I've actually had I looked at the answers and I had to correct something from the answers. I've been pretty good so far, you must admit. Okay, so our last question. Whoop-de-doo. Okay, so getting on, approaching 10:30. I'm just going to delete everything. Delete and it gets a lot of stuff. Why aren't you working? I want you to go away. Maybe this is a glitch. I'll forget it. I've got enough space up here. There's only one more question. All right, if A plus B plus C equals 0, prove algebraically that A cross B equals B cross C. Okay. All right, let's give it some thought. A cross B cross C equals 0. Now, you guys are aware what that looks like. If you just followed it like it was position A to position B to position C, it forms a closed circuit if it equals 0. Okay. So I'm going to write that. Let's pick one more color. I'm going to go with I'm going to do this in hot pink. Why not? So that's the given part. You're allowed to use that without proof, because that was a little free gift. That was a free prize. You've won that from making it this far into your test. Now, with the proof, you've got to start with one side and achieve the other. So I'm going to start with the A times B side, and I'm going to approach the B times C side. And you're going to wonder, oh, how on earth are you going to do that? Well, let's see, shall we? Start off by running that. I've got my memory what I want to get. I want to end up, and I'm running it down on a piece of paper here. My final answer will be B cross C. That's what I want. That's what I'm going to do. Now, the final answer doesn't have an A. So let's think about that. How can we express A as something else? Well, how about let's look at this. It was given to us as a free gift. A can be expressed as neg B, neg C. Yeah, let's move those across. How about that? Would you look at that? So now I don't have any more A's. Okay, now, first of all, expand that out. Now, this is kind of expansion. You got to get the order correct. So in other words, that one's fine because it was B and B. Even the negative doesn't matter that much in that context. What does matter is this one needs to be in the correct order. C to the left, B to the right. I'll explain why in a minute. But yeah, now if you've done matrix algebra, as I mentioned, most of you should have, because you should have been taught the 3x3 determinant before you do vectors and specialist. But I know the person who's taking math studies in my school at the moment, we didn't have this discussion because I taught last year, and I've been teaching math studies for about 8 years solid at school. I decided I want to try something different, so I'm still keeping specialist and physics, but I decided, hey, I'll try something different. I'm going to do numeracy, which I kind of like. It's different. I just teach kids I wouldn't teach regularly, and I just teach them a lot of little life skills like how to set up cookie menus. It's actually kind of fun, and I get different kind of kids, and they're fun. They don't really want to be there, but we make it fun, and we have little chats, and we have a little chuckle and such, and we're not busting our heads with vectors and such. So yeah, if anyone needs help with that kind of stuff, and I hope when I get the open question thing done, people just send me any maths and any questions they got, anything they're interested in. Because and throw me stuff I don't know, especially. So I'll take time and learn things. I want to learn stuff as well when I do this. I want to aim higher than what I've achieved so far, and I want to go right down to the bottom. I want to go right down to little kids having trouble with adding things up, and they've got too few fingers. They've adding to 11. And they don't. It's all jokey to make my best mate at primary school. They say, look, you got to stop counting your fingers. You're going to run out of fingers. And sure enough, one day he was asked to add 6 and 8. And he started doing his fingers, and he realized, nuts, I ran out of fingers. So what do I do? And he started counting his toes. He kind of just filled his toes and said, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I've done 6, and I've done 4 out of the 8. Okay, 1, 2, 3, 4 toes. So what have I done? I've got 4 toes, 10 fingers, 14. Excellent. But of course, then the problem comes. What happens when you go beyond 20? He starts counting hairs on his head. No, I'm just joking. Okay, let's finish this off. Sorry. I'm I'm mumbling nonsense again. Now, what happens when you take the cross product of the same vector? Is 0. Just you should remember that from your set of definitions. So that essentially that's neg 0. Now, minus c cross b. I'll just write that out one more time. Okay, and I'll simplify that. Now, okay, explain the last bit. Now, vectors, I'll just put a little note here. Something that should be, you should remember this. This is why I made a point earlier that multiplication of real numbers, the change of direction doesn't matter. The multiplication in the vector product cross product does matter, and it matters like this. If you reverse the direction of the cross product, you reverse the direction of your resulting vector, which is why one must always be negative of the other. Okay, I'll let that sink in. If you change, you swap your A and your B and your cross product as I've written here. If you swap those around, you end up with a vector which is in the opposite direction, same length, opposite direction. So if you think about, okay, well, how do I make them equal? Well, one has to be the negative of the other to change the direction back to the same direction. So thereby, A cross B equals minus B cross A. Okay, how does that help what we're doing here? Well, let's look at this. This must be positive B cross C. Boom. We've got our final answer. Again, I spent a lot of time talking that through, so hopefully how I did that sinks in. Well, yeah, well, this has been fun, as usual. So you guys celebrate a successful watching of this stream, and yeah, keep doing your homework, and I will catch you out there. All right. See you later.